So hi children, in this video we are going to discuss about that irrational numbers. Okay, so after that rational we are having that irrational numbers. So here irrational numbers means what? The numbers which cannot be expressed in the form of p by q, which cannot be expressed in a p by q form. So rational numbers means a number which can be expressed in a p by q form, which cannot be expressed in p by q form. Those numbers are known as irrational numbers. Okay, a number which cannot be, a number which cannot be expressed in p by q form, and p comma q where belongs to z, q not equals to z, and here we cannot be write in that form of p by q. So how we can express that p by q form? Okay, so here we can observe up to p by q form which cannot be expressed, okay. Here I am going to give you that root 2, okay, root 2. Here you may get that down to root 2 by 1, okay. Previous I told you that any number, any integer given means by 1 we can take, but here why can't you express that root 2 by 1? In that rational numbers, what I told you that in that rational numbers, integers we can express in the form of p by q, okay. So here p by q I written, no, that p by q should be integer, then only we can express in that fractional form, okay. But here root 2 is there, root 2 is not an integer, no, root 2 is not an integer. That's why here we cannot write this one in the form of root 2 by 1. Root 2 by 1 is equal to, again you will get that root 2 only. Root 2 by 1. Root 2 by 1. Again you will get that root 2 only. But here root 2 is not an integer. Root 2 not belongs to integer. Okay, that's why here this is not a rational number, that is an irrational number. 1.414 something you will get, okay. After simplifying this root 2 you will get that 1.414 something you will get, okay. That's why here root 2 we cannot express in the form of p by q, okay. So here example for that irrational numbers, root 2, root 3, root 5 and so on. What about that root 4? Root 4 is a rational number or irrational number? That is a rational number, not an irrational number. Why? Because root 4 we can express that 2 whole square. 2 square is 4 and here square and root gets cancelled. So again you will get that 2 as a resultant. 2 as a resultant. 2 is an integer or not? Yes, 2 is a positive integer. Okay. That's why this is belongs to q means what? A rational number. So root 4 is a rational number and the left over root 2, root 3, root 5, root 7. Okay, root 9 again that is a rational number. Root 9, 3 is that value, so that is a rational number. So root 7, after that we are having that root 11 and so on. These all numbers are irrational numbers. These all numbers are irrational numbers. So by which letter we have to represent that irrational numbers? Yes, that is q dash. Q dash. Q means rational numbers and q dash is nothing but irrational numbers representation. Okay. So here other numbers also there for that irrational. Those are pi. Pi is an irrational number. Why? Because simply we can observe that pi is equals to 22 by 7. In generally we are saying pi is equals to, the value of pi is equals to 22 by 7. But that is not exact value. Okay, for our calculation in general we are using that pi is equal to 22 by 7, but that is not an exact value of that pi. That is the assumed value of pi. Okay, so that is the assumed value of pi. That's why here we can, after simplifying that 22 by 7 you will get that a rational part, I mean a rational number only. 22 by 7. After simplifying that 22 by 7 you will get, in your material also you can observe that in that rational numbers they are given that in rational numbers also pi given and irrational numbers also pi given. How it is possible? Either that number should be a rational or that is a irrational. Okay, those two also possible. Is it possible? In that rational, pi given. In that irrational also pi given. How it is possible? Why? Because just our mathematicians, they given that assumed value of pi. Assumed value of pi, that is 22 by 7. So after simplifying that 22 by 7, you will get here non-terminating recurring decimal. That's why in that case pi is a rational they given for that assumed value. Okay, but pi is not having that exact value, we can't say no. So that's why here pi is an irrational number only. Okay, for that simplification only they given in that rational form, but that is an irrational number. So anywhere pi is an which number, if anybody will ask you in that examination, they will ask you the question pi is related to rational number or irrational. Always pi is an irrational number. Pi is an irrational number only. Next, e. E is equals to 1 point something you will get here. So E value also we cannot say that, we cannot express in that P by Q form. Okay. So pi E, these two are a very important thing, just keep in your brain. Pi and E, those two are always irrational numbers. Okay. And the leftover root 2, root 3, root 5, root 7 and so on. Okay. So this is about that irrational numbers. So after that irrational numbers, we will discuss about that real numbers. So after that real numbers. So real numbers means the combination of the combination of rational numbers and irrational numbers are called real numbers. Okay, so here real numbers means the combination of rational numbers and irrational numbers are called real numbers. So in that real numbers you can observe that rational numbers and irrational numbers also. So which means in that real numbers we can observe all integers, fraction parts, negative fractions, positive fractions, root values, okay, square root values also you can observe. Okay, those all values, those all numbers we will call them as real numbers. Okay, at that starting of that class, in that starting video I told you about that flow chart. In that flow chart you can observe that okay, real numbers is the combination of rational numbers and irrational numbers. So in rational numbers we can say up to integers and fraction parts also, no. So including with that, in irrational part we can observe that root values also. So the combination of rational numbers and irrational numbers, those all numbers we will call them as real numbers. Real numbers represented with the letter R. Real numbers represented with the letter capital R. So R is equals to, here we can observe that rational numbers as well as we can observe that irrational numbers also. So set of rational numbers and irrational numbers we will call them as real numbers. That's it. Nothing is there to discuss about the real numbers here. You can read about the real numbers in the 10th class. Okay, this is the 10th class concept. In real numbers you can observe that logarithm values, so and so. Okay, we will discuss that one later. So after that real numbers we have to learn about that imaginary numbers. Imaginary numbers. So here imaginary numbers means the square root of negative numbers. The square root of negative numbers are called imaginary numbers. Are called imaginary numbers. Okay, once see here, what is that? The square root of negative numbers are called imaginary numbers. So, here square root of negative numbers. Come to that real numbers, what I told you that in that real numbers we can observe that rational numbers and irrational numbers. In that irrational numbers, what I told you that in that irrational numbers we can observe that the square root of positive numbers. Okay, square root of 2, square root of 5, square root of 3, square root of 7 and so on. Okay, 2, 3, 5, 7, 11, those all numbers are positive numbers only, no, positive values. But here imaginary numbers means the square root of negative values. The square root of negative numbers are called imaginary numbers. So that is simply we can write then square root of minus 1, square root of minus 2, square root of minus 3. Okay, negative values. So, imaginary numbers, the starting letter of imaginary, starting letter is I. So, imaginary numbers represented with the letter small I. Imaginary numbers represented the letter small I. So, generally the value of small I is square root of minus 1. Square root of minus 1. So, I is equals to the value is square root of minus 1. Okay. Why I kept here star marks? Because that is very, very important. Okay, so what is the value of I? Imaginary number. What is the value of I? Means square root of minus 1. We will call that I is called iota. We will call that I as iota. Okay, so here what is the value of I? I is equals to square root of minus 1 and we know that square root is there. So if you convert that one into that LHS, square root become as a square. So I square is equals to minus 1. Okay, from this condition only I written that generally the value of I is square root of minus 1. Okay, from this one only I written here I square is equals to minus 1. I square is equal to minus 1. So here once we will discuss about that I is equals to square root of minus 1. I square is equals to minus 1. What about I cube? I power 4, I power 2000, I power 3000, I power 9999. Okay, I power 1 lakh. Those all values also we can find any value I power something we can find that. But how to find? Okay, that one we will see here. Okay, so I is equals to square root of minus 1. From this condition we can write that I square is equals to minus 1. I square is equal to minus 1. Now I want to know the value of I cube. I want to know the value of I cube. So I cube how I can write? Here I know the value of I power 1 and I square. Those two values also I know, no? So that's why here this I cube we can express it as I square into I. Shall I write like that? In that exponents we can observe this law, that is a power m into a power n is equals to a power m plus n. We can observe that law of exponent in that exponents concept. Okay, so that is one of the main law here. According to that condition here I square into I power 1. So we can write this according to this one, I power 2 plus 1 which is equals to I cube. This is that law. Okay, by using that law I written here I square into I. Okay, so now here I square is equals to, we know the value, that is a minus 1, and here I is equals to what is that value? Again square root of minus 1. So no need to write that square root of minus 1, or if you want to write means you can write also. Okay, so minus 1 into square root of minus 1. So we will get this one as a minus of square root of minus 1. Minus of square root of minus 1. Okay, so this one, or again we can write this one as a minus I. Why? Because square root of minus 1. In these two forms also question will be asked. What is that? I cube is equals to minus of square root of minus 1 or I cube is equals to minus I. Okay, in that options we can observe any one of these two. Okay, either that is minus of square root of minus 1 or minus I. Okay, those two also correct options only. Okay, so the value of I cube. So at last the value of I cube is equals to minus I, simply we can write. Okay, based on this I will tell you that how to find that remaining values. Okay, so let us say that I power 4. I power 4, how we can express according to this one? I square into I square. Mostly take that one as I square. If you know that previous value, then you can substitute that value here. So I square is equals to minus 1, and again I square is equals to minus 1. So minus 1 into minus 1 is equals to plus 1. So I power 4 is equals to 1. So what is the value of here I power 4? I power 4 value is 1, positive 1. Okay, so let us see that the values of I is equals to square root of minus 1, I square is equals to minus 1, I cube is equals to minus I power 4 is equals to 1. Okay, let us see that values here. So let us see here, I is equals to square root of minus 1, I square is equals to minus 1, I cube is equals to minus I power 4 is equals to 1. If you know these 4 values, then you can find that any value. Okay, just see here I am going to take I power 6. I power 6 value I want to find. So I power 6, how I can write? I square into I power 4. Shall I write like that? Why? Because I know the value of I square and I power 4 also. That's why I written this one in I square into I4 formula, that is. So I power 6 is equals to I square is nothing but minus 1. And here I power 4 is 1. Okay, so minus 1 into 1 is equals to I power 6 is equals to minus 1. Okay, next I want to find the value of I power 8. I power 8. Okay, so I power 8 value, how we can find? Okay, just say that I power 4 into I power 4. Shall I write like that? I power 4 into I power 4. Here into symbol is there, but we can express this one as I power 4 plus 4. So again I power 8. According to that law of exponent, a power m into a power n is equals to a power m plus n. According to that condition. Okay, so I power 4 value is 1 and I power 4 value again 1. So 1 into 1 is nothing but equals to 1. So I power 8 value is equals to 1. Here we can observe that I power 8 is equals to 1. Okay, keep that one aside. Now I want to know the value of I power 12. I want to know the value of I power 12. So I power 12, I can write this one as I power 4 into I power 4 into I power 4. Shall I write like that? Why? Because this is, we can write it as I power 4 plus 4 is equals to I power 12. 4 plus 4, 8. 8 plus 4 is equals to 12. So we will get that one as I power 12. Okay. So I power 4 is equals to value is 1 into I power 4 is equals to 1 into I power 4 is equals to 1. So 1 into 1 into 1 is equals to, again we will get that 1 only. Okay. So what is the value of I power 12? 1. Here maybe you may get the doubt, why madam is writing here I power 4, I power 8, I power 12 values only, why she is not writing I power 6, I power 7 values. I will tell you that. Okay, just observe that here I power 4 value is 1, I power 8 value is 1, I power 12 value is 1. Okay, so I power 4 into 1, which is equals to I power 4. Okay. Next, I power 4 into 2, which is equals to I power 8. I power 4 into 3, which is equals to I power 12. Yes or no, once observe that. So we can express this one as 4 into 1, 4 into 2, 4 into 3. So and in the same way, I power 4 into n is equals to I power 4n. The number which is in the form of I power 4n. Here what is this value? I power 4 is 1. I power 8 is 1. I power 12 is 1. So and in the same way I power 4n value is 1. Okay. If that number is in the form of I power 4n. Okay. 4 into something. Then its value simply, no need to simplify this all everything. Okay. Just we have to keep that these 4 values in your brain. Easily you can calculate that values. Okay, so I power, the number is in the form of I power 4n, always that value is equals to 1. Okay, let us see one example. I power 2024. This year I taken here 2024. How big number it is? Okay, just a 4-digit number. No need to worry about this one. Why? Because I power 2024. How we can calculate these all? Here these all numbers are in single digits and 2 digits, but here 4 digits. Just simply convert this one into the form of here 2024. First you have to observe that exponent. It's a power. Once you have to observe 2024. That number, is it divided by 4 or not? Once we have to check. So 4 5 20 and 4 6 24. So 0 and 4 6 24. So 4 into 506 is equals to 2024. Yes or no? So that's why we can express this number as 4 into 506. I power 4 into 506. Now this is in the form of I power 4n only, no? So simply this value is equals to 1. Simply I power 2024 value is 1. Okay. So what about that I power 2025? I power 2024 is 1. What about I power 2025? Here also same only. I power 4 into 506 is equals to 2024. Still we have that 1. Still we have that 1. Now this one we can write it as I power 4 into 506. Now this is in the form of a power m plus n. So we can divide this one into a power m into a power n formula. So plus, into I power 1 is there, no, 1 is there means we can write it as I power 1 also, no. Okay. So I power 1 is nothing but I only. So I power 4n into I. Shall we write like that? Why? Because again 4n plus 1. I power 1 is there means 4n plus 1. What is the value of I power 4n? Which is equals to 1 into I. So its value is equals to I. So what is the value of I power 2025? Which is equals to I. Okay. So in this way we can find that remaining values. In that worksheet again we will discuss about that the problems related to I power something. Okay, that is related to imaginary numbers. Okay, after this one we have to discuss about that complex numbers. Okay, that is the last one. Okay, so what about that complex numbers means the combination of real numbers and imaginary numbers. Imaginary numbers are called complex numbers. Are called complex numbers. The combination of real numbers and imaginary numbers are called complex numbers. So the combination of real numbers. So let us say that A is a real number here, plus or minus. Here IB also we can take. IB means I is an irrational number and B is a real number. Okay, so AB belongs to real numbers and I is an imaginary number. The number which is in the form of A plus or minus IB. Okay, then we will call those numbers are complex numbers. Let's take one example, 2 plus or minus root 3 or root minus 3 something. The numbers which are in the form of A. Here what about that B? When you compare these two numbers, A is equals to 2 and I is equals to square root of minus 3. Where is that B here? Here B is there, here B is not there. Then which one is B? Nothing is there means we can consider it as a 1, no? So that's why B is equals to 1. Okay, 1 into root 3. That is again root 3. 1 into square root of minus 3 is also square root of minus 3. Okay, so the numbers which are in this form, either that is positive or plus or minus in between those two, okay, we will call this type of numbers are complex numbers. So up to here what we discussed, these all are the types of numbers. Okay, so once again I am recalling that types of numbers. The first type of number is the natural numbers, which is represented by n. Next one, whole numbers, which is represented by W. Next, integers, Okay, integers represented by I or Z. Next, rational numbers represented by Q. Next, irrational numbers represented by Q dash. Next, real numbers representation with R. Next one, imaginary numbers represented by the letter small I. Okay, next, these are complex numbers, means this is in the form of a plus or minus ib. Okay, if that numbers are in this form, then we will call those numbers are complex numbers. So if you observe that the flow chart, then you can see that these all. Okay, so in that flow chart we came from that downwards to topward. At starting in that flow chart we can observe the heading as complex numbers. In that complex numbers we have that real numbers and imaginary. In that real numbers we have that rational numbers, irrational numbers. Next, in that rational numbers we can observe that fractions and integers. And in that integers we can observe that 0, positive integers and negative integers. Next, here 0 and positive integers are whole numbers, and in that whole numbers we can observe that 0 and natural numbers. In that natural numbers we can observe that even numbers, odd numbers, prime numbers, composite numbers. So that is the flow chart. So still up to here, in these all videos we discussed about this flow chart only. Okay, we can observe the flow chart in that single screen. I written that flow chart, but here this much of concept is there related to that flow chart, and this is very important concept. Okay, so up to here types of numbers completed. So in that next video we will discuss about that worksheets. After that completion of that worksheet, we will discuss about that properties of each type of number. Okay.